Hey guys, this is AO12, simplifying algebraic powers. This is actually the last AO we need to look at, but it's actually one of the more complex ones, so this is going to take a little while, so bear with me. Now, just before we jump into this AO, I do want to just clarify something really important about the difference between this video, AO12, and the first video we did, AO1, and that was simplifying like terms. When we were simplifying like terms, we talked about how we couldn't simplify values like x squared and x cubed. Now, this is only true when you are adding those together. You can't add apples and oranges. What we're going to be looking at today isn't adding x squared and x cubed or unknown values of different powers, but multiplying them. And it's a very different thing. So we're not going to be dealing with any of these addition problems today like this. So let's get rid of that. We're going to be dealing with multiplication, division, squaring, cubing, to the power ofs, and we're also going to be dealing with square roots. So let's have a look at this. So the first question we're going to look at is here. X squared times x to the power of 6. In order to answer this question, I'm just going to break this down a little bit. I'm just going to go really simplistic with this explanation. So let's get into that. I'm going to break this up into its parts. So like, what is x squared? Well, x squared is x times x. What is x to the power of 6? Let's write it over here. It's x times x times x times x times x times x. He does a quick check to make sure that he's calculated it 6 times. Good. Now, when you're multiplying them, what you're essentially doing is you could just rewrite it like this. Now, just for clarification's point, where I've put the little dots in between, I'm using that to replace the multiplication sign because it would look a little weird if it was x times x, So we're multiplying these two values, x squared and x to the power of 6, and what you can see is you've essentially got x to the power of 8. Because, well, what's the difference between this times and this times and this times, etc., etc., etc.? So what we've done here is we've gone x to the power of 2 times x to the power of 6 is x to the power of 8. And you can see that really clearly when we visually set it out as to, why that is true. What some of you may have noticed already is that x to the power of 8 is the same as taking our 2 and adding it to our 6. It's a really interesting concept, and it does make sense, right? You've got 2x's over here, you've got 6x's over here, you've kind of added them together. We call this adding the indices. All right, let's have a look at our next question. So this time around we're doing 4x squared times 5x to the power of 6. So let's break this down. Over here we've now got 4, I'll put a dot there, 4 times x, and this is, why do I keep doing x to the power of 6? Making my life difficult. There we go. Same thing again, we're going to multiply these. Now, we can simplify them. We're actually going to simplify these guys first. What is 5 times 4? I mean, we can rearrange this. We can put them next to each other. It's no problem. What's 5 times 4? That is 20. Okay, and how many x's have I got now? Well, I've got 8. I'm sure some of you have already counted that. So, there's my answer. I have multiplied these guys together. That makes logic. And I've added those indices. And you can see I could essentially go through and add up those x's again. But that's all we've done. So 4x squared times 5x to the power of 6 is 20x to the power of 8. So that's multiplication. In that case, what we've essentially done is we've added the indices. If we're doing this our answer would be x a plus b. Now we're going to have a look at division questions. And what we're doing here is the same concept, it's just the reverse. So let's write this first one out in its full expansion. X, 2, 3, 4, 5. And it's divided by x times x. Now, these x's are just going to cancel each other out. X times x divided by x, no matter what it is always going to equal 1. You can put any value in there for x. 5 divided by 5, 1. 20 divided by 20, 1. So it's always going to be 1. So we're just going to basically end up cancelling these things out. So that divided by that is going to leave us with 1. Well, anything multiplied by 1 just leaves us with that original value. So they actually end up just cancelling each other out. And so this one here, doing again, 2 cancelled out. What are we left with? Well, x to the power of 3. Our answer is just x to the power of 3. And some of you would have already noticed that is the same as going 5 minus 3. So very similar to what we had up here with our addition, except this time around we're subtracting the indices as opposed to adding the indices. Okay, well, what about this question? Let's expand this one out. Oh, do I want to write? Yeah, I'm not going to write all that. So let's think about this logically. We're going to have, we've got 2 x's down here. We've got 8 x's up there. 2 of those are going to cancel out 2 of those. So we're going to be left with x to the power of 6. That's logical. And, well, we know 16 divided by 2. 16 divided by 2 is 8. So there's our answer. 8x to the power of 6. So once again, we've got a sort of a simplification of that rule. If we go x a divided by x b, it's going to equal x a minus b. That's our sort of our simplification of that division indices rule there. Okay, so those are the first two. That side of the page is messy, but we're just going to leave it there. It's going to be fine. It's fine. Just ignore it. Just ignore it. We're going to now move on to looking at powers of powers, which is pretty much the coolest sounding thing you can have in maths, right? Powers of powers. That's what we're going to be looking at. So, what do we do now? This question over here. X to the power of 6 to the power of 2. Okay, right. That's crazy. Let's write this out. Oh, why did I do to the power of 6? Oh. Okay. X to the power of 6 looks like this. Looks like this. To the power of 2, I'm basically timesing it by itself again, right? So, well, here's another x to the power of 6. Oh, the dot's not really in the right place. And I'm timesing it by itself, so there's the dot there for the timesing by itself. So how many x's have I got now? Well, I've now got x to the power of 12. And some of you would have already noticed that, well, that is essentially 6 times 2. So that's what we've done here. We have gone, well, 6 x to the power of 6 times x to the power of 6. I mean, you could just essentially rewrite it like this and treat it in the exact same way we treated the last questions. X to the power of 6, x to the power of 6. I mean, it's the same thing. So we just add in the indice rules again. Or doubling. Well, what about the next question? Let's have a look at this. X to the power of 5 times 3. So x to the power of 5 times x to the power of 5 times x to the power of 5. Well, let's just use our rules from this side to help us out. It's just going to be 5 plus 5 plus 5. It's our indice rules again. We could go through and write out all 15 x's, but I'm running out of page. So x to the power of 15. And once again, that is essentially just 5 times 3. Last one. Let's have a look at this last multiplication one. So I'm doing 5 to the power 5x to the power of 5 to the power of 3. Ooh, it's a mouthful sometimes. 5x to the power of 5, 5x to the power of 5, 5x to the power of 5. Now, I do have to go through and do 5 times 5 times 5. There's no special workaround for this one. So 5 times 5 times 5 is 125. 125. And x to the power of 15 again. So 125x to the power of 15. So if we want to write like a generalization for this one, what we'd say is if it is a to the power x to the power of a to the power of b, it is going to be a x to the power of a times b. That's your little indices shorthand there. Last but not least, square roots. Now, square roots. Let's just clarify and make sure we understand what this here means. Now, the square root is the opposite of squaring. So, as an example, if 3 squared equals 9, well then the square root of 9 is 3. So, let's think about that and how that affects. Now, what you're essentially doing is you're undoing to the power of. So if we go back up and have a look at this first question here, that first question, just to rewrite it, was this. And we decided that that was going to be this. So we decided x to the power of 6 to the power of 2 was x to the power of 12. If I wanted to undo that, I would square root it, and that would leave me with x to the power of 6. So what we're kind of doing here is we're undoing what happened there. Now what happened there was we times that indice by 2. So what we're doing here is we're dividing that indice by 2. Does that make sense? So here we went 6 times 2 was 12. So if we're square rooting, we're essentially dividing this power here by 2. We're doing the opposite of what happened up here. So in the example of our question, our first question that we have here, our answer is going to be x to the power of 3. We are halving 6. We're halving that 6. Let's have a look at our bottom question. Well, what we're going to do here, we still have to square root this like we ordinarily would with any other 16, like we would with any, like we would if it was just 16, the square root of 16. So the square root of 16 is 4, so that is 4. Let's just get rid of that. But what do we do with the indice? Well, we halve the indice, so it is to the power of 8. So this is 4x to the power of 8. All right. After all that, little summary, let's write a little summary up for this one. So if we're doing this to the power of a, then the answer is x a divided by 2. There we go. That's a little summary. Okay, so this is your opportunity to shine. This is your time to test yourself, to see what you've learned. So here are the questions that I want you to attempt. Dun, dun, dun. Now, give them a shot. If you find yourself stuck, if you find yourself confused, feel free to backtrack, go back through the video, watch it again. We went through a lot of stuff very quickly. So try some of these questions, or try all of these questions. Unpause the video and I'll go through and explain the answers. So what I want you to do now is pause the video, do what you need to do, and then once you have some answers, once you want them to be checked, unpause this video. Off you go. All right, and we're back. So let's give this thing a shot. All right, now what are we going to do here? We're going to add the indices. This is x to the power of 7. All right, next one, what are we going to do here? We have to multiply the 3 and the 6 there. So that's going to be 18. We still have to add the indices. So that is 9. So 18 x to the power of 9. C. Okay, we are subtracting the indices, so we're going to be left with x to the power of 3. Alright, what are we going to do here? Now we have to divide these like normal. So that's going to be 5, and then we're going to subtract the indices. So we're going to be left with that, 5x to the power of 4. Alright, moving on to E. So with x to the power of 8 to the power of 2, we're just going to multiply those indices, which means we're going to be left with x to the power of 16. On to the next one. All right, we'll do the same thing here again. So this is going to be x to the power of 12. Yep, that's correct. 3 to the power of 12. Okay. Next one. Oh, no, I have to cube 2. So 2 times 2 times 2, 4 8s. And then I'm going to just multiply those indices again. Same indices again. Sneaky, sneaky. X to the power of 12. So 8x to the power of 12. All right, the last two questions. Now I'm square rooting these indices. I'm going to half that, so that is x to the power of 4. And last but not least, the square root of 49 is 7, and the square root of x to the power of 10 is x to the power of 5. So there we go, 7x to the power of 5. Now, hopefully you got all those correct. If you didn't, go back, review the information, ask some other students, check some other tutorials out online, come and ask me. I'm always here to help. If you did get it correct, that's absolutely fantastic. It's really tough, really challenging part of algebra to get your head around. But once you actually stop, like with a lot of algebra, once you stop and you think about actually what the question is asking you, it's very logical. And while this page might seem like a hell of a lot of scribble, there's a lot of logic and there's a lot of prior knowledge built into this. So while algebra often appears really, really scary, it's just applied logic. So well done, guys. That was AO12, simplifying algebraic powers. That's actually the last video that we have in this series for now. So keep an eye out on that one. Well done, and hopefully I'll see you guys again soon.